And as you know, this meeting is recorded and will be uploaded to public internet. So with that, let's start the meeting. I have a few updates for you guys. Let me just pull up the meeting notes quickly. I don't know if Vinay is here today.
Here, Bobby.
Yeah, hi Vinay. Let's just start with you. Since you may not be interested in the rest of the meeting, I let you start, and I can actually give a quick update about what this topic is, and then we can discuss it, and then after that you can feel free to disconnect if you want. For other folks, I have actually put a link to our meeting notes about the issue or the PR that is sent, which is a proposal actually for in-place updates of pods. So the idea behind in-place update of pods is that sometimes pods require to change the resource requirements that they have. For example, pods may need more CPU or memory. In those cases, we would like to have a system which automatically changes those resource requirements. This is especially needed because a lot of users don't know how much their pods require. And even if they know, these requirements often change during the course of execution of many pods. For example, a server may suddenly get more traffic. As a result, it needs more CPU, more memory, etc. So we would like to build a system that automatically changes these resource requirements based on the actual usage of pods. There is a proposal. I just sent a link to the proposal. We already have actually a mechanism for changing resource requirements of pods, but the current existing mechanism requires pods to be restarted after these changes are applied. What we are pursuing is another approach that does not require or doesn't necessarily require a restart. And that's the subject of our discussion today. There are some design decisions that we would like to make, and Vinay is going to give us a quick introduction to the problem we're discussing, and then we can have a quick chat. Hopefully, we can resolve the issue. Go ahead, Vinay.
Okay, thank you, Bobby. So the issue that in this proposal that we were looking at there, the backstory is that there have been a couple of design proposals over the past year, and our design proposal, we looked at this issue where how to get in-place update happen and what the flow should be, control flow should be, who the initiators are. The initiating actor in our case is a job controller. Our customer requirements stem from a long-running job where having max resources allocated for the peak usage is expensive, and they wanted to see if they could get something that can scale up and scale down as the resource needs increase and decrease. The main use case here is VPA, which is currently using pod restart mechanism and hooking into the admission controller to update the resource requirements on a pod that's being created and before it's scheduled. The proposal that we worked on, the design that we worked on, it involves keeping the scheduler in the loop. Today, what we have is we see that when you create a new pod, the controller goes and creates a pod, and then the scheduler sees that a pod's been created that's not bound, and it goes and looks at its predicates, runs its predicates on the pod, and one of the predicates is a resource check and finds the best node for it to assign and picks a node and assigns it to it. The flow that we want to use is similar. We want to keep the scheduler in the loop, so we look at this as an extension. Okay, we change the resources, and since scheduler has a view of what resources are available where, it needs to know that the resource is being updated. So as part of this, the flow that we were looking to do is have the scheduler pick up the resource update first and then either say yes or no. And the proposal that Carol has here, which is what I'm planning to merge, accounts for one other case where scheduler can preempt lower priority pods and get things going, which was not covered in our proposal. The issue with the current flow that's there in the proposal is that the kubelet and the scheduler act on the update request at the same time. And let me just, can I share the screen, Bobby? I'll just do this.
I think you
It's
can.
easier to do.
Are you sharing it now? I'm not sharing it now.
All right. Can everyone see the screen?
Yeah, we can see the screen.
Okay, so this particular comment that we have, just going into the details of this one, it looks like Bobby already commented, and thank you, Bobby, for looking at this particular issue here. So the issue that I was looking at, the current proposal has, we update the resource requirements after validation. It's updated in the pod spec. Then the scheduler checks the pod first and preempts. At the same time, kubelet tries to apply. This is where we saw a potential race condition, and we have documented that in this example. The issue is that if kubelet and scheduler are acting at the same time, then we could end up in a situation where the kubelet takes the request and applies it. Scheduler is at that time working on scheduling another pod to the node against the capacity which it sees is available, and it schedules that pod and then rejects this update request. And then the scheduled pod goes to the kubelet, and kubelet sees it doesn't fit and rejects it, and the initiating actor will have to kubelet then processes the update request and fails it, saying, okay, no, this node is full, I cannot do this update now. And initiating actor has to take that pod out, and now kubelet's work is kind of double because it has to schedule pod P2 again, and then P1 gets scheduled because initiating actor most likely will kill and then create the pod, which increases the kubelet's workload overall. So this is the point that I felt was an issue. And I'm working on a flow proposal that's more in line with what's being proposed right now in terms of there are some nice things to Carol's approach, where he's reusing existing pod condition and container statuses. So I'm writing some quick and dirty code to test it out and see if there are no major gotchas here in applying. Our approach has used, for the controller side, BPA is one use case where BPA will look at it and see if the Kubernetes system is not able to do the in-place update. It'll reschedule the pod so that it gets the resources sooner than rather than waiting. The job controller approach we're looking at is to have the controller have some smart retry mechanisms where, okay, if the in-place failed and it has to be done in place, then what we're going to do is we're going to look at pods leaving that node, and when pods leave that node, there's potential that capacity has opened up, and then we retry. That way we are not burdening the scheduler with random retries, and it's done when there is a certain expectation that it should succeed.
I see. Yeah, thank you very much for the update. So with respect to the race condition that you initially mentioned, and is also, I know your screen is also showing, I actually went and read the whole thing, and I agree that it's not a good idea to have like racy sort of algorithms between two components. As you mentioned, it causes extra activity in various modules, including the scheduler, which is sort of like a precious resource for us, especially in larger clusters. If this happens a lot, it could impact negatively the scheduling throughput. So we prefer to remove the races as much as possible. I would like to hear what Carol is thinking about this approach, but at this point at least, I agree with you that we should wait for the scheduler approval before letting kubelet to act on the resize request. And
okay.
yeah.
I'll follow up with Carol as well.
Okay.
Another question that I was looking into, Derek had raised this concern about gamification of the resources. So, and then Carol had suggested using max resources, max of resource allocated versus resource requested or the desired resources. And I'm trying to understand that a little bit more closely, mainly from the perspective of it does seem to like act more on the conservative side, and which is good. You will end up in a situation where you're not over provisioning any node. The one one thing I was looking at is that going to cause a lot of resource wastage if I'm trying to investigate that a little bit more. Based on your previous conversations with Carol or Derek, do you have an idea of what kind of scenarios
So
the gamification can happen?
yeah, I don't actually quite remember this exact problem. My memory is not that good. So maybe we probably had this conversation, but I don't recall exactly. So do you know what exactly this max resources is used? I mean, alternatively, if you're okay with like having different QoS classes, we could use like limits. Um, right, for setting the maximum, to indicate the maximum resources that a VPA could go for a particular pod, right? So I don't exactly remember what was the max resources used for.
Oh, in this case, it looks like there is a resource allocated and there is a resources desired, which is in the new proposal. Today we have resources, which is the desired resources, which is going to be there once the pod is scheduled. It's going to be scheduled against what's desired. And now we have this resource desired changes, and resource allocated has to come in. Our job, the cluster's job, is to bring it equal to make them equal, get the resource allocated to the resources desired.
Yeah.
So in that, at any point of time, what he's saying is, whichever is higher, take that for accounting, not the lower one. And that seems to have something to do with the gamification that I think Derek had commented on my design document earlier. I'm trying to better understand what exactly that is.
Okay, I don't exactly remember, but taking the maximum doesn't make sense to me, because
Yeah,
sometimes we may require to reduce the resources requested by a pod, right?
yes, and during the reduction also it might work out in the sense that okay, the your desired resources is now lower than the actual resources. When you're accounting for it, you account for the max so that you're not over provisioning, or you're like, to take a simple example, let's say there is one node with one pod which is using all the capacity,
Now I see
and
what you're thinking.
then its capacity is the scheduler reduces it to half, and then another new pod comes for scheduling, which can fit on that node. The one potential problem I see is, okay, the scheduler goes and reduces the capacity and tells kubelet, okay, go ahead and reduce its capacity. The kubelet hasn't seen that update yet. And then this new pod comes in, gets scheduled to that same node. Now, if these two updates are reordered, then the scheduled pod will get rejected. That is one potential I see. Do you see that happening in? Could that happen?
Yeah, it would. It would. If they don't take
Oh,
the maximum, it would. So yeah. So I think now it makes sense to me to take maximum of the two. Otherwise, we could run into the scenario that you just described. Basically, the scheduler may assign pods to nodes. Nodes don't have enough capacity, so some pods could get rejected in that process. So.
okay. That's what I was trying to wrap my head around today and understand more closely what it exactly means. And maybe that's what the gamification term that Derek used refers to. I'll
Yeah.
follow up with Derek and then see if this is what he meant. And this particular scenario is what Carol and Derek were worried about. As far as the rest of the document goes, I believe you had a couple of more questions in there. One was about clarification that scheduler is in the loop. Has that been clarified for you?
Yeah, it is clear. But later on down in the document, I commented that we should probably have a better flow, because the flow is currently missing in this document. I know that you have it in other documents, but the flow is currently missing in this document. And
Right.
without that, having without the flow, it's hard to really tell what the algorithm is and
Yes.
if there is any major issue. So that was my comment. Yeah, that's basically.
Okay, I'll take these new parameters that Carol has, and probably tomorrow I'll be able to finish my quick prototype and verify. So the only outstanding issue in this, which there is no good solution, is when you have two schedulers acting independently. And in that case, the best thing to do is the scheduler sees that the kubelet has failed the update request, and it deducts, let's say it's an increase, and then the kubelet can detect scheduler can detect a transition, the old pod, new pod. It can see the transition from requested to failed. So I'm planning to add one more state in there called requested, which the kubelet sets when it agrees, and then it sees that state going from requested to failed. It knows that the accounting that it had added for is not valid anymore. It can deduct it.
Yeah.
So
we can basically we can add some logic to the scheduler to not insist on the same node that has failed. Basically, the basic of the idea is to accept the fact that there is race condition and try to deal with it, right?
Yes.
So if it happens, we should not insist on the same decision that we have made already because it has failed. Maybe scheduler can try a different node, although we don't have any of that, and the scheduler logic, basically scheduler does not keep any history, so maybe we need to add that. But that's one approach, but there could be other options as well.
Yeah, the approach we have taken is to keep schedulers simple. The controller, the initiating actor, in this case, it could be VPA or the controller or job controller, would see that it has failed and then retry it. And we were looking at a couple of different policies. So in the case of job controller, when it sees that it has failed and it goes and retries it at a later point when pods leave, and we use the reason field in the pod condition to specify why it failed. It failed because of capacity. Okay, the node doesn't have capacity. It will have capacity when pods leave, and this is something the controller has a view of. So the controller can decide, okay, now is a good time when a pod that a guaranteed or burstable pod leaves the node, now is a good time to retry. The other case is when you have deployment controllers where you're resizing all the instances of the pod, and if the resize requires restarting, then you could violate the pod description budget. So if the scheduler says, okay, if I do this, the pod description budget is violated, so I'm not going to do it, I'm going to fail it, then the controller can retry when the pod description budget is restored again. So those are the two conditions that we have taken care of in our code. VPA might have other ideas of how to handle it. I think they were looking at awaiting, and then where the scheduler takes the task of kicking out low priority pods, which makes sense because the outside of Kubernetes cluster, nobody has control. The control is with the scheduler and controllers to see if they can move low priority pods off the node so that the higher priority pods can get the resources that they desire.
Yeah, so there are, as you said, there are multiple options. In the interest of time, let's stop this discussion. We can follow up on this later, and we can actually have more discussions on the document as well once it's a little bit more complete.
Yeah, we'll do that. Thanks, Bobby.
Thanks very much for the update. Yeah, sure.
I'll jump off now. Thank you.
Sure, thanks. All right, so there are a couple other updates. I go quickly over those. So another one is the fact that we had a major issue with taint nodes by condition that caused a problem, and there were for that. In the past, we tried to change kubelet and add logic to add taint to the nodes at the startup, but it caused some upgrade issues. So we are now pursuing a different approach, basically changing the API server to basically taint nodes at creation time. So it looks like the PR is now ready to get merged, and we will cherry pick this change to older releases, basically since 1.12. Hopefully this will resolve some of those issues. Another issue we have faced recently, Ray has been working on this, is that the scheduler sometimes leaves some pods in pending state and not retry these pods. So as some of you may already be aware, we have had a logic in the scheduler to not retry unschedulable pods until there is a change in the cluster that makes pods more schedulable. For example, node updates and stuff like that. In the past, scheduler was reacting and retrying all these unschedulable pods at every node heartbeat, which was arriving at like every 10 seconds from each node. So in a larger cluster, it would happen very frequently. Nowadays, scheduler is more efficient, but we know that there could be some races where a scheduler could possibly miss some of these events when it's trying a pod. And if that pod, which is in flight, is determined to be unschedulable, then sometimes this pod may not be retried. So we have had a mechanism to retry some of these pending pods, but that mechanism is only in the master. We may need to cherry pick that into older releases to solve this issue. I will follow up with Ray on this. These are updates from my side. I know that many of you guys are present today in a meeting. Are there any comments, updates from any of you folks that you want to share with us? All right. So Valerie, I know that you have raised interest for one of our issues, which is non-preempting priority functions. I do support adding that feature. I'm not so sure if I will have enough time to help with fixing the problems in the existing PR for this feature. But if you think you can help us with that feature, I would really appreciate your help. All right, that's that.
Out of curiosity for that issue, who would be the best people who kind of own that area right now to talk to?
So, I would be probably the person to contact. But so what is the exact problem? Are you looking for someone to find what the solution is, or have you already seen that PR that is already there but is causing build failures?
I've taken a look. I've only worked in the networking and testing areas so far, so there's just a lot of areas of the code base that are new to me with that.
Sure. Yeah. I mean, for helping with the code base and sort of like mentoring people, I don't know if I will find enough time, to be honest with you. I will be happy to answer maybe some questions which are a little bit more quick, but some of them which need to require more time, it's really hard for me at this point.
So if I may, SIG Contribex has been working on the mentoring program for a long time to try to meet needs like this. If it's something like a code-based tour or help on a particular PR. And so I think it's quite likely that the knowledge that's needed is not just in Bobby's head, but somewhere in this SIG among a few of us. And so I think, one, asking this SIG who has time for example, a code-based tour is one step, but another would be finding the landing page for the mentoring program to see if putting in a request is the right path for this particular issue.
Yeah, these are all great points. Thanks, Jonathan. So these are all great points. You can seek help there. And in fact, the failure that we are seeing is not in the scheduler code. It's actually more on the API side. So it falls mostly in the API machinery and how the APIs should be added. And since this change is touching the API, there is some amount of work to be done there, some amount of code that should be automatically generated, and we should make sure that we are touching the right places to ensure that all these new codes are generated properly. And I'm pretty sure that the failure we're seeing is because of that. Seeking help from SIG contributors is probably the best approach at this point.
Okay.
Yeah, thank you. All right, any other questions or comments or updates from projects you guys are working on? Okay. One quick thing, Harry, I know that you and one of your colleagues, I believe, has been working on equivalence cache or equivalence class at this point. I guess it's not quite a cache, it's more like a class. I'm sorry that I haven't had the chance to take a look at the PR, but it's in my to-do list. I will definitely take a look, and hopefully we can get that going soon.
Yeah, just take your time.
Yeah, thank you. So if there's no other questions or comments, we can end the meeting now. All right, thank you, everyone. I'll see some of you folks next week. Bye.